This lecture is on average atomic mass. So when you are looking at a periodic table, you're going to see two numbers generally on it. One's going to be the atomic number, which we are used to now. That's the whole number. It gives us our protons, gives us our electrons if it's neutral. And then there's also going to be another number on there, which sometimes we use as a reference for about what the mass is. But what that number is the average atomic mass. So what you want to think about is isotopes, how there's many forms of something like carbon or many forms of something like oxygen. What that number on the table represents is the average of all the masses of all of the versions of carbon. So it's the average of all the masses of carbon-12 plus carbon-13 plus carbon-14. So it's an average, which is why it's a decimal form. So now what we're going to do is we're going to figure out how do we find that number on the periodic table. 2 steps. Not very hard, but if you don't do things correctly, it can give you the wrong answer. So it's important for you to pay attention to these rules here. The first step is to multiply the exact mass that you are given by the percentage of abundance. Now, the important part here is that you most likely will be given the values in percentages. We want this to be in decimal form. So when you are given a percentage, you want to immediately convert that percentage to a decimal form. Think back to math class. How do you get there? You either divide by 100 or you move your decimal to the left 2 spots. Okay? So one of those 2 ways, either way is going to get you the same number, but whatever works for you. Step number 2 is you're going to add each isotope together. Now, make sure you have these written down. We're going to go to a problem, and you're going to want to reference back to these 2 rules. So I've not written these in word form, just in number form. When you look at practice problems, they are going to be written into kind of word problem type. So just make sure that you're actually reading out the information, and what you want to do first is pull the information from that problem that you need so you're not left with all of the other things that are written in the problem. So we have an isotope of carbon-12 and we have an isotope of carbon-13. That's what we have right here. So remember that this number right here represents your mass. This just tells you the element. And what this is saying is that we have that 98.90% of all carbon is carbon-12. 1.10% of all carbon is carbon-13. Now, let's look at those steps again. Step 1 being to multiply each isotope by the atomic mass that we are given. So our first one is we are going to multiply 12 by our percentage of abundance, but remember that has to be in decimal form, so that's going to be 0.9890. Then we're going to multiply our carbon-13 by our percentage, also needs to be in decimal form, 0.0110. Something I see a lot with numbers like this one, where it's a single digit, so 2%, 3%, 4%, is I see a lot of writing, like let's say if we had 4%, I see a lot of writing it like this, 0.4. Remember that you have to move that decimal 2 spots. That's 1 spot, that's 2, so it's 0.04, okay? So make sure that you are writing it correctly in decimal form. Don't just guess. Actually think about what it is that you are writing. All right, so now we have to multiply each. So when we multiply 12 times 0.9890, we get 11.868. You should also be doing this on the calculator to make sure that you are getting these same answers. Multiplying 13 by 0.0110, we get 0.143. Now step 2 is to add these together, and we get 12.011, and then our units on this is AMU, which means atomic mass units. It's just another unit like meters, liters, grams, bytes, joules, all of those that you've been seeing already. Atomic mass units is just your units of mass. Okay, easy enough. Let's take a look at another example here. We have rubidium 85 at an abundance of 72.2%, and rubidium 87 at an abundance of 27.8%. So step number 1, multiply your mass up here by your abundance, which is right here. Remember that abundance needs to be in decimal form. I'm just going to write the other one out here. 87 times 0.278. Multiply this out, we get 61.37. Make sure that you are doing this as well. 87 times 0.278 gives me 24.186. Then we add these together and we get 85.556. Now, what I want you to do is take a look at your answer and make sure that it makes sense. So, if 72% of my rubidium has a mass of 85 and 27.8% has a mass of 87, it can only be between these two numbers. There is no rubidium, according to this problem, that is less than 85, and there is no rubidium, according to this problem, that is greater than 87. So if you're getting an answer that is less than 85 or greater than 87, then you did something wrong. Because if you total these two numbers, 72.2 plus 27.8, you get 100%. So this accounts for all of the rubidium in the problem. So if you're getting a number outside of the range between these two, something went wrong. So make sure that your answer makes sense before you actually submit that. And remember, you also need your units here at the end. So here is a practice problem for you. Chlorine 35 has an abundance of 75.53%, and chlorine 37 has an abundance of 24.47%. Go ahead, pause this, and do the problem, and then come back when you are finished to check your answer. Okay, if you remember from doing isotopes, this number right here afterwards is just another form of us writing isotope notation. So that is just another way of us writing the mass of this specific isotope. So chlorine 35 has a mass of 35, chlorine 37 has a mass of 37. Convert both of these into decimal. So we have 35 times 0.7553, 37 times 0.2447. That gives me 26.4355 and 9.0539. Add them together, 35.4894. That is a value that makes sense because it's between the values in my problem. One last thing, AMUs. Okay. Here's another example. I want you to try this one. We have magnesium 24 that has a percentage of abundance of 78.70%. Magnesium 25 that has an abundance of 10.13%. And the remainder is magnesium 26. So I'm going to give you a clue to get you started here. When we are doing any of these problems, your abundance should total 100%. So get this written down. Take a little bit of time, try and get through this problem, then come back and check your answer. Okay, so the first thing that you needed to do was to find this value right here, the remainder of it being magnesium. So if you add up the 78.7 and the 10.13, and then you subtract that from 100%, you should be left with 11.17%, which gives you what you're left with for the magnesium 26. So then we're just going to multiply. We moved our decimal over 2 spots. That gives us this. 25 comes down. Move your decimal 2 spots. That comes here. Magnesium 26. Move our decimal 2 spots. That comes here. Multiply, multiply, multiply. Then we add them together and you should get 24.3247 AMUs. Go ahead, do some practice problems on these. Make sure that your answer makes sense. That's what I can tell you the best. And also make sure that you are moving that decimal 2 spots and not just to the front of your number, because if not, you're not going to get something that makes sense. Check those answers and let me know if you have any problems.